Let's start the review for section 4.4. Between what two consecutive integers must log base 5 of 12 lie? Well, let's look at what the log represents. We're looking for the exponent that we need to raise the base. In our case, the base is 5 and the argument is 12. So what's the exponent that I need to raise the base, which is 5? So that's equal to 12. That's what this is trying to figure out. So 5 to what power gives you 12? Let's check. 5 to the 0, that's equal to 1. 5 to the 1, that's equal to 5. 5 squared, that's 25. So I know 5 to what power gives me 12? Well, it's got to be between 5 and 25. So what's the exponent? The exponent has to be between 1 and 2. So log base 5 of 12 has to be less than 2, but it has to also be bigger than 1. I know log base 5 of 12 is between 1 and 2. Question 2, find the exact value of log 10 to the 4. Now when we write log 10 to the 4, there is no base here, so you have to assume this is base 10. What are we asking? We're asking 10 raised to what power is equivalent to the argument, and the argument is 10 to the 4th. 10 to what power equals 10 to the 4th? Well, that's pretty easy. This missing number has to be equal to 4. We know this missing number has to be 4 in order to be equivalent to 10 to the 4th. So log 10 to the 4th is exactly 4, and we didn't even need a calculator to do the problem. Again, if there's no base here, assume it's base 10. Question 3, find the exact value again. Notice we don't have a base, so let's assume it's base 10. So we're asking the question, 10 to what power gives me 0.0001? Now notice that this number is less than 1. So that means this exponent must be a negative. 10 to a negative exponent is going to give me 0.0001. So let's figure that out. You can use a calculator to guess, but I can look at these decimal places here. That's 1, 2, 3, 4. I need to move the decimal place 4 times to the right to make it a 1. So I know 10 to the negative 4 is equivalent to 0.0001. And you can clearly check with the calculator that this is indeed true. So that's our answer. It's negative 4. And we did this problem without a calculator. Question 4, let's use our calculator to find the approximations for the common logarithms. When we say common logarithms, we're going to use base 10. Type these in your calculator, and let's see if you get the same answers. If you don't, make sure you ask questions on how to use your specific model calculator. I'm going to go to Google and use their calculator. Let's try the first one, log of 447.5. 447.5. Push enter, and we have our solution is 2.651 approximately. For part B, we're going to do the same process, but this time we're going to enter log of 44.75. Enter log 44.75, click equals, and our solution is 1.651. And finally, for part C, it's 4.475. We'll type in log 4.475. This gives us 0.651. 0.651. So practice again on your calculator, making sure you get the same approximate values. Question 5. Use the base change theorem to find the logarithm. Recall log base b of x is equal to log base a of x divided by log base a of b. This formula says I can choose any base that I want in order to figure out something that I do not know the log of with a certain base. So here, we know that our calculators don't have base 1/4, but I do have a base 10, which is log, and I do have a base e, which is natural log. So both of these will work. We can convert it to any base that we want, either base 10 with log or base e with natural log. So this is equivalent to log of 2 divided by log of 1/4, and that's going to give us our solution. You can also use natural log. You can use natural log of 2 divided by the natural log of 1/4. Either way, we're going to get the same answer. So let's try that on our Google calculator. And then we're going to divide that by the natural log of 1/4. Let's click enter and let's see our solution. It's negative 0.5. Negative 0.5. And double check with your calculator. If you use natural log or log, they're going to give you the same answer. We're using the base change formula and using any base that we want. We'll use base 10 or base e since that's what our calculator has. In question 6, which of the following is equivalent to 2 natural log of 10x, where x is greater than 0? For the first expression, I can use the product rule. This is equivalent to the natural log of 100x. Now, it doesn't look like our expression 2 natural log of 10x, so let's keep going. For the second expression, this is equivalent to the natural log of 20 plus the natural log of x. That's using the product rule again. So that doesn't really look similar to our original expression. So let's go on to the next one. I can combine these, and that's natural log of 20x for the third one. Now for the fourth one, that looks like it has a chance to being equivalent to 2 natural log of 10x. So let's try that out. If I rewrite this, I can rewrite this as natural log of 10x squared. Now notice we can bring this 2 to the front. So this is equivalent to 2 natural log of 10x. And that's exactly what we want. So the last option is equivalent.